together and figure this information out. So here, there's going to be a lot of math in here. And you can think of the math that we're doing today is going to be very similar to geometry. Now, we're going to do it together to figure it out. But then we're going to be able to, it's going to take us a while, but then you can use this to give you your answer. So that was the one from yesterday. I'm going to keep referencing it. I put it here so that I can keep going back and forth because we want to continue looking at it. What the? All right. So, we know 68% of our area. From here to here, we know that this is 68% of all of what we should see. Now, we also know that we're going to use the idea of symmetry. Since the normal model is perfectly symmetrical, what does that tell you about this section right here and this section right here? Since it's perfectly symmetrical, what do we know about those areas? Is perfectly symmetrical.
They're the same median.
No. It is. We're there. So think about this. We're going to get to the answer in a little bit. But what does this area? Don't draw this. But what is this section? And what is this section? They're what? No, area is always positive. So no matter what, the area is going to be positive. Yes, one has negative z-scores, but what do we know about this area? So we have this area, which I'll call area 1. And we have this area, which I'll call area 2. What do we know about area 1 and area 2? What do we know about this area and this area? They're next to each other. We know more. They make up the highest portions. That's true. What do we know about, think about it. Just looking at it, what does that look like? And remember, we know that this is perfectly symmetrical. What do we know? What can we decipher from this area here and this area here? Which one? No, they don't. It's symmetrical. What does symmetrical mean? What does that tell us? If we folded it?
Perfect symmetry.
Maybe perfectly? It's perfectly in half. That's one way to think of it.
What you said is right.
What is it?
You said it's the same on both sides.
And that's what we're looking for. It's the same on both sides. They have, because it is perfectly symmetrical, this area here is the same as this area here. They are exactly the same. So as such, because they are exactly the same, this whole thing is 68%. So if they're exactly the same, then how much is each one? How did you get that? I divided in 2. Since both of them together is 68%, that means that this area here, what is it? It's just picking up every little thing right now. Let me take this, I know, stand middle. This area here is 34%.
Is it still doing it?
Yeah. And this area here is percent. Okay? Now, how much of our data, man, why is there so much lines? How much of ours is above here? How much is above here and how much is over here?
Make sure you're copying this down the back.
How much? So how much total area is there? How much total? What is the everything? What would everything be? What percentage would everything be? 100%. Okay. If 68% is here, how much is left over? 32%. How much is to the right? How much is just to the right? If the whole thing is 32%, then how much is on both sides of that then? 16%. So from knowing that this middle portion is 68%, we know that each of those two little pieces is 34%, and we also know that all the way to the right, more than 1 standard deviation above the mean is 16%, less than 1 standard deviation below the mean is also 16%. All right. Let's change the color on here. We also know that this is 95%. Yes? So if this is 95%, what's half of 95%? What is half of 95%? 47.5%. So that means, and I'm not going to write that number on here, that means that from here to here, from here to here is 47.5%. Yes? Does everybody see that? So how much is this part then? How much is that section? How do we find that mathematically? If I know the whole thing is 47.5%, and know the other piece is 34%, minus 34%, which gives us 13.5%. So that section there is 13.5%. Now, if I add these two together, 34% plus 13.5%, I get 47.5%, which is half of the 98. Which means that this other side, what is this area right here? What is this little segment of area? What is that area right here? Because it's mirrored, because it's symmetrical. I mean, by knowing one, I know the other side. Now you can see why there's so much time for notes. You can see where I'm making us do this together. Now, don't worry. Here's the goal. You don't have to relearn everything we're about to learn. Because you can look it up here. Now, how much is here and how much is here? So we're trying to find this one right here. How much is this area all right here? How much does this area right here? My question that I'm trying to ask you. There we go. Why did you get that? Yes, that is correct. 60 okay, you did it that way. Okay, so we know this is all 16%, and since this is 13.5, yes, that was going to do it a different way. Yes.
Okay, but like I already know.
So the other way I was going to explain it, if we know this is 95%, what percent is left over? Deviations. All right, now the next piece. We know that, let me go here. We know that from here to here is 99.7%, right? If that whole thing is 99.7%, how much is each of these two going to add up to? Well, remember, we already know that this is 68% from here to here, right? So from here to here is 68%, or 95%, sorry. And from here to here is 99.7%. What does this have to be, or what do these two have to add up to then? What's the difference between 95% and 99.7%? What? 99.7 minus 95. 99.7, your number's way too big. 99.7 minus 95 is 4.7, but this is only half of that, so we divide that by 2, and we get 2.35%. And this on the other side is 2.35%. So that's 2.35%. All right, Chloe, you can use Chloe's math. What does this last little piece have to be then? After we've done all this, what is that little tiny sliver right in there? What is this right there? That little tiny sliver of area right at the very, very end. I'm talking about this little piece right here. That is what percentage of the total area? Close. There we go. 0.15%. Not 15%, but 0.15%. Because if that's 2.5, then that's right here. And then that means this down here is 0.15%. Okay? So I did lie. We're going to do one example. We're going to do an IQ test example. You can do it on the end of your homework, your notes from yesterday. So if you pull out your notes from yesterday, we're going to do the same question about IQ scores. Our goal is to be done like 5 minutes early, or at least 10 minutes early. So hopefully this will only take us 10 minutes, 5 to 10 minutes at most. Okay, leaving you more than enough time. So we're going to do an example, and we're going to use this. Okay, so let's do it our example. Same problem as yesterday. What is going on? It's like it's not picking up. Why is it? Example. IQ scores are normal. It's the same one, normally distributed. With a mean equal to 100 points and standard deviation equal to 16 points. Question A. What percent of IQ scores are greater? How many standard deviations is 132? From yesterday's, we know that this model looks like this, right? Here it is. Then we have 1, 2, 3. 1, 2, 3. Here's 100, 116, 132, which is right there, right? There's 132. And so if I'm shading, sketching this, I want to know what this area is right here, which is 2 standard deviations. 2 standard deviations. So what is the area above 2 standard deviations above the mean? 2.5. Please look at your sketch, look at your model from version 2 right now, and see why Tree is saying it's 2.5%. He is correct. Look at that. Do you see why? Because this right here, 132, is the same thing, as 2 standard deviations above the mean. It is 2 standard deviations. 132 is at 2 standard deviations, and that area that is greater is 2.5%. Okay, nice simple question. You see how you can use that version 2?
Yeah.
All right, last question to have for you today. B. What percent of IQ scores are between 84 and 148. Sketch to show. What are between 84 and 148? What percent is between 84 and 148?
68 or 34.
No, it's much, much greater than that.
On your paper before you call it.
The answer is not going to be any of those numbers that you see directly on the paper of version 2. You're not going to see it perfectly there, but the numbers are there so that you can do the math to do it. Did you get it? What is it? Huh? From -1 standard deviations to 2 standard deviations. So what Tree first has seen is this. He knows that here's 0, or here's 100. Here's 84, which is -1 standard deviation. 1, 2, and here's 140, or sorry, 116, 132, and 148, which is 3 standard deviations. Okay? So now we can use the visual. Now, there's 2 ways you can do this. You can just add up each individual slice if you want to. Okay? Or we can use the 68, 95, 99.7. Which one do you want to do? Or we want to do a combination of the both? There we go. So I know that between 1 standard deviation, -1 and 1, that this right here is what percentage? What percentage falls between here and here? 68%. You could also have just broken that up as 34% and 34%. What is this next little piece? No. Don't go beyond. What is the next little piece? What's that next section? Look at your version 2.
34.
No. What is the next little? Okay, so let me break them up individually. Basically, I know I have these sections right here. This is 34%. This is 34%. What's the next one? What's the next one? 13.5%. What's the next one? 2.5%. Stop. That's where we want to go to. Yep, add them up. 34 plus 34 plus 13.5 plus 2.35. I add up these numbers because that's all of the sections that I want from version 2. From -1 standard deviation up to 3 standard deviations. You get it?
81.40 is the answer.
It looks about right. Is that right? Does anybody else confirm? 81.4%. Let me double check. 68 plus 13.5 plus 2.35. No, I'm getting slightly off.
It's okay, Sam.
I'm getting, I think you forgot that 2.35, Sam. 83.85%. 83.85%. I think, yeah, I just missed that last little 2.35 and missing that one is what Sam did. She got the first 3, but the 4th section right there. And that's it. So 83.85% of individuals have IQ scores between an 84 and 148. That's our lesson for today. We still have about 5 minutes. Use that time on your own.